Welcome everyone. In this video, we'll talk about how to write out resulting equation after performing a particular transformations to a given family of functions. So I have three examples for you here. We'll write down the equations of the final transformed graph. First, let's give ourselves a recall. What are the transformations that we should know? So here are the rules, just a few. Of course, there are a couple more that I have not mentioned here. You should look them up if you're not familiar with them. So these are kind of like the rules we want to remember. So suppose C is a positive number. And if you have y equals f of x plus c, then you're going to shift the graph of f of x upward c units. And so if you have f of x minus c, you're going to shift down c units. The third rule, if there's a horizontal shift right here, that's a horizontal shift. If it's f of x minus c, you're going to shift to the right c units. So as this one, if you have f of x plus, you're going to go to the left c unit. And then these two rules are for reflections. If you have negative f of x, so we turn y values negative. To obtain that graph, we reflect over the x-axis. And similarly, if we have negative in here, negative f of negative x, that's a reflection about the y-axis. So we're turning all the input values negative. Okay, so having said that, now let's take a look at how we can find the equation of the following transformed graph. For number one, we're starting with x squared, that is your f of x, and you're going to go down 7 units. All right, so down 7 units, meaning we're using this rule right here. That's a vertical shift. So a resulting equation for 1, it's going to be f of x is going to be x squared minus 7. So we went down 7 units. And if you want to graph it, feel free to do that. But since we're not graphing in this video, we'll leave this as our final resulting equation. For the second one, we're going to start off with absolute value of x, and then we're going to shift 4 units to the left. So that's using this rule right here. That means we're shifting horizontally 4 units to the left. That means we're going to have the first, let's write down a rule. We're going to do f of x left. So we're going to have plus c, but c is 4 in this case. This is 4 units to the left. So this will give us our resulting equation as absolute value of x plus 4. Now from there, our second transformation, we're going in order. So the second transformation will apply. It's going to be shifting down 3 units. So again, we'll take our function f of x and then down, so that's minus c. So this is 3 in this problem. So here I'm using rule number 2. So our final equation, picking up from step number 1, that will be absolute value of x plus 4. So that was shifted 4 units to the left and now down 3. That is your final result. So our final equation, you can call it f of x if you like. It's going to be this equation. All right, so that is the answer to 2. And for the last one, number 3, we are going to take again absolute value. First, we're going to reflect about the x-axis. So that means our function will have negative y values. So that's how it's going to look, which means the resulting equation will be negative absolute value of x. And then, so that is step number 1. Then step number 2, we're going to shift 2 units to the right. So that's using rule number 3, 2 units to the right. So we will do, we'll take the one above, and then we're going to do x minus 2. That's 2 units to the right, which means our resulting equation is negative x, absolute value of x minus 2. And lastly, we're going to shift up 6 units, again, taking up from the previous step. So we'll take that result, call that f of x, and then go up 6 units, so plus 6. So here I'm using rule number 1. So again, I take my previous result. I have negative absolute value of x minus 2 plus 6. And that is our final equation. So we can say our result, or transformed graph, is f of x equals negative absolute value of x minus 2 plus 6. That will be the resulting equation. All right, I hope this makes sense. I'll see you next time. Take care, everyone.